trig integrals. So remember, these are ones where we're going to have to remember all of our trig identities and know how to convert between two different types of trig functions. So for 2a, we have the integral of tan cubed. Alright, so you have particular rules when you have function or integrals that involve powers of tangent and secant. In this case, you're always going to try to break it down as far as possible and try to get the derivative of one of them to come out into the function. And the best way to do that for this one is to split that into tan and tan squared and use an identity for tan squared. So this is the same thing as tangent of x times secant squared x minus 1. So tan squared is secant squared minus 1. So, and dx. And you can see that when I distribute this tangent, I actually just get the integrals of tan x secant squared x minus the integral of tan x. Have dx's. Okay. The antiderivative of tan x is something you can either just memorize or view it in terms of a substitution, which I'll get to in a second. The first one here is actually even easier, because if you notice, secant squared is the derivative of tan x. So if you have the derivative of something in the function, you just want to use u substitution. So you can solve the first integral by saying u equals tan x. You can see then that du is secant squared x dx, and this becomes the integral of u du. Now, just be careful that if you're going to do substitution again for this one, because I'm going to do this one by not doing the identity, don't use the same u, because then you'll be confused about plugging it back in afterwards. So this one up here is the same thing as the integral of sine x over cosine x. And you can see this is going to be a natural log, because we have the derivative of the top, or sorry, we have the derivative of the bottom on the top. So remember, functions of the form du over u are always going to be natural log functions. Well, all we need for that to be a natural log function is to put a negative, because the derivative of cosine x is negative sine x. If we put a negative there, we have to put an extra negative in front, and considering it was already negative, that's going to make it positive. So this is plus the integral of negative sine x over cosine x dx, and that's just ln of cosine. The antiderivative of u is just u squared over 2, and remember that our u was tan x, so this is going to be tan squared x over 2 plus our ln of cosine x plus c. So when you get these integrals where you have to do things with the trigonometric functions, you're absolutely just going to have to know all your identities, all your Pythagorean identities, all your double angle identities, all of those things. Sometimes some of them can get to be just kind of trial and error in a sense, but if you want to practice these a lot, you're going to start recognizing patterns and being able to do these much quicker.